Our lab basically is interested in looking at conversion of sunlight into energy. The reason this, solar cells or photovoltaics are very important is because if you go across campus or across anywhere in Houston and you talk about the energy transition, where you want to get to a net zero CO2 emission by 2030 or reduce it by at least 50%, the only way to get there is to have enough renewable electricity. We've been working a lot over the last several years now on this new class of semiconductors which are known as perovskites or halide perovskites. And so these are basically materials that are solution processable, which means I can take powders and crystals of these, dissolve it in solutions, and then coat them like you would coat paint, right, using processes, and make solar cells and other type of devices with them.
Perovskite solar cells are kind of the holy grail of this new solar cell technology, and that's because perovskites can be made, in theory, significantly cheaper than inorganic solar cells like silicon or gallium arsenide. The reason why is because they can be solution processed at low temperature. Basically, you can take an ink of a perovskite precursor and you can spread it across a piece of glass and then heat it up, and then you have a perovskite.
The biggest snag in all of this has been long duration stability. How can we make these solar cells so that they last in the field for 20 years? That's been the biggest challenge. And so this result here uses a specific composition of the perovskite that the world has been trying to stabilize, we've shown that we can stabilize this using another class of perovskites which are known as two-dimensional perovskites.
So the pink in there are very tiny microscopic crystals of that 2D perovskite additive that we've put in. And they're distributed across the entire film, so when we heat this up, all of those crystals of the 2D perovskite that already look like the correct phase are going to basically work as like puzzle pieces or Lego pieces.
And so when they mix together, the bulk perovskite or the 3D perovskite comes and sits perfectly well with the 2D perovskites and provides just a little bit of compression to it. And that makes these perovskites, which are typically in the 3D perovskites, this composition which was in the yellow phase, which is not the solar cell phase, into a black phase which starts absorbing light and then becomes, provides a material that's extremely stable to temperature, light, humidity, and so that's what we've demonstrated.